Software Engineering Radio Episode 54, interview with Frank Buschmann.
Welcome to a new episode on Software Engineering Radio. This time we have an interview with Frank Buschmann. On the microphone is Michael. Frank, your name is associated with patterns, Kloster-Irsee, or better Euroblob, and of course the POSA series, where POSA stands for Pattern-Oriented Software Architecture, which is a book series by Wiley. Why don't you introduce yourself a bit?
My name is Frank Buschmann. I'm 46 years old, and I've been in the domain of software development and software architecture since about 30 years now. I studied computer science in Dortmund and learned about objects in 1983, learning Simula 67, and started my professional career in 1990 at Siemens Corporate Technology, where I'm still with that unit today. And since then, I worked in the field of software development, software architecture, with a specific focus on technologies like frameworks, product lines, patterns, components, and services.
So, where are your roots? What is basically the concept or the technologies that shaped your career at the end?
I think it was patterns. And why I came into patterns was a very simple thing. When I started my work at Siemens as a consultant in projects, I realized quickly that I'm rediscovering things again and again. So reinventing the wheel in each project I was on. And I thought myself, hey, you are a lazy guy, so you can document your knowledge, your design knowledge in that case, so that you have it readily available on new projects so that I could be a little more lazier. That was the first idea of my pattern work, and that was in 1992. And soon I discovered that other people were on that theme as well, like the Gang of Four, like Bruce Anderson, like Jim Kaplan, or Grady Booch. And from there it went on and became what it is today. So that is probably my predominant technology. And the other topic that influenced me very much because it allowed me access to the international community was my work on the C++ Standards Committee, where I met people like Bjarne Strustrup, and in that context also Kristen Nygaard, the inventor of Simula 67. Both persons were my mentors, introduced me to other people.
So how was it like at those days? How was it different from today?
We simply had a little more time to think about and reflect about things than today. Today everything is time to market driven. Technology hypes are coming and going more quickly than they were in the past. We simply had more time to elaborate the technology, prove its feasibility, and transfer it into production or productive software development. Today everything must go quicker and quicker. Innovation cycles became shorter and shorter. So the focus is on something that works out of the box quickly. And since no technology actually can fulfill this expectation, more and more technologies are invented. That is my impression. The wheel is turning much, much faster today.
So how was it basically at the time when Goff was written and POSA 1 was written? Were you in contact with Gang of Four?
Yes. There was a kind of competition between the two teams. When we learned that the Gang of Four was working on their book, we also started working on POSA 1. That was in 1993. And interestingly enough, there was a big overlap of the patterns. So in POSA 1, in the original manuscript of the book, a whole set of patterns that is now published in the Gänge Vor book was also present, which is a good thing because it was a proof that these designer ideas are really patterns. But we lost, let's say, the competition they published earlier, so we kicked out all of the patterns that the Gänge Vor published, with 2 exceptions where we described different variants.
So, and Golf was published in 1995, I believe?
In 1994, and we had our draft ready in 1995.
Okay, and was then published in 96.
Yes, due to some production problems.
I remember there is this award you have, the Scholt Award. So how did that come?
I actually have no clue. That was a big surprise. Neither us nor Wiley nominated this book as a candidate for this award. So it was a complete surprise for us, and I don't know who the nominator actually was. But nevertheless, we won that award, and I still have this the prize, which is a can of Jolt Coke on my desk.
So what is this award exactly about? Does it still exist today?
It still exists today, and it awards outstanding works in various disciplines of software, such as books and projects and things.
What are you doing in your daily work, and how do patterns influence your daily work?
In my daily work, I am working on concrete projects, doing architecture coaching, and also mentoring software architects. I take them by hand and show them the issues they need to address. Patterns play an important role. When I do concrete stuff on projects, I not only do coaching, but for some topics that are hard to resolve, where the project has not the right people on. I also do design. And in this work, patterns play an important role. They allow me to address things to the point, and they also allow me to enter or to learn about technical domains I'm not the big expert in, to get a foot into the door. So I read all the pattern books that I can get to learn about the concepts. Of course, there are good books and bad books, and I have to distinguish carefully between things I can use in my daily work and things I should better not use. But nevertheless, they help me doing my daily job.
There is also the conference we mentioned, Euroblob, and at the SE Radio, we actually had some episodes that we recorded at that conference. For example, the interview with James Noble. I guess you were the one who started the Euroblob series.
Right. That was in 1996. There we had the first European conference on pattern languages of program design. This is the official name. And it was motivated by the US PLOP conference. I had the luck to attend the very first PLOP conference in Monticello, Illinois, which is a remote place in the middle of nowhere. And I actually enjoyed this remoteness, this retreat character of the conference, where just 40 people met to discuss things without being disturbed and interrupted by daily work, by phones, by email. At that time, Monticello had one phone for all of us. At that time, mobile phones were not commodity. Islam, not available. So it was really a remote setting where we spent the entire day and the nights discussing patterns, discussing other things about software, discussing projects, and having fun. And I thought this idea is worth to be reused and adapted to a European setting. And I started working on the idea of setting up a European conference on patterns. That took me 2 years, and the most difficult part was to get a slot in Kloster Irse's schedule. They're pretty much booked for the entire year, and space for 65 people was not easy to acquire or to assign. So it took more than a year just to get in.
So because we're just about the past, I know that you attended the first Hillside meeting, and we once talked about some anecdotes that you experienced during that meeting.
No, it's not quite true. I didn't attend the very first Hillside meeting. That was 2 or 3 years before I joined that cabal. My first exposure to Hillside was in 1994 at the OOP conference in Munich, where I met Jim Kaplan and showed him what we did in our pattern work at that time. He was quite surprised to see that somebody at Siemens or somebody at Europe was actually working on the subject as well, in addition to himself, Gänge 4 and others. So he introduced me to Kent Beck, who was also at the conference, talking about CRC cards. And we met at a bar in the evening, showed Kent our pattern works, and both invited me the next day to join Hillside. So I attended the first Hillside meeting, I think it was in 1994.
And that was at a Hillside?
No, that's the first meeting. The first meeting of Hillside was at a Hillside. The first meeting was held in Colorado in Grady Butch's house, and he lives in the mountains. So that was the first Hillside meeting, and there the name comes from.
So what influence did the patterns have over the past 10 years, let's say? How did they change the software development community, the best practices?
I think it was a kind of revolution. When the Gänge 4 book was in production, or we worked on patterns in the early 90s, it was a kind of eye-opener to us. All of us a language, a vocabulary to express design ideas to the point, with all the pros and cons, with the liabilities, with benefits, the solutions, the forces, all what we think is common sense today was absolutely new in the early 90s. We could talk about design, we could assess design, and we could inform our activities. What do we do here to address this or that problem? We had an expression for requirements, and an expression to transform requirements into working solutions. And that, I think, is commodity. Without patterns, I don't think any successful software development is possible at all. They are common sense, and the enormous success of all the pattern books in this world is a documentation of that success. Still, the Gänge 4 book is considered the most successful book on software design in this world ever. POSA 1 and POSA 2 are considered as to be amongst the top 5 books that had most influence on the field of software architecture. So at one of the very first meetings, also my first Hillside meeting, we had the idea of changing the world, the software world. And looking back onto what we achieved, I think it quite became true.
You mentioned architecting with patterns. This is a question that I often get asked. How do you really work with patterns? How do you architect with patterns? Is there any guidance you could give in some brief sentences?
Yes, of course there is some guidance. Important are requirements. The application you are developing should always swing the baton, which means without requirements that your solution must fulfill, all design work, with or without pattern, is just guessing at best. So start out with the requirements. If you have a specific challenge to master, such as cooperating components consistent, or high performance event handling, pick up and document the concrete requirements, speak forces you expect from the solution to this challenge or problem. And then you can match the concrete requirements of your application against the forces of corresponding patterns that address this type of problem. And if the forces match, well, you have passed the first step. The second step is, and that many people actually forget this, each pattern comes with a cost. There's no free lunch. So you should look at the consequences, specifically that, first of all, the benefits correspond to the forces and not something different. There may be additional benefits, but if the forces are not resolved, well, then the pattern is of no use. And second, to the liabilities, the potential drawbacks. Sometimes they are not relevant for your problem, sometimes they are. Sometimes you can afford the liabilities or drawbacks, and sometimes you can't. And if you can't afford them, well, you shouldn't apply the pattern. Once you have reached that point, you can look at the concrete solution. The most important advice I can give is look at requirements of your application, then look at the problem forces of the pattern, then look at the consequences, the good and the bad, and then you can work on the concrete solution. What roles does the pattern introduce? What cooperation between these roles is happening? And how do you implement the thing? Rather than starting with a solution in search of a problem, you start with a problem and work towards the solution. Another important suggestion I can give is there's more than one solution to almost each problem. And for many problems in software, more than one pattern is documented. There is no single iteration. There is no single state pattern. There are a whole range of patterns for different types of problem. And look on these alternatives. The documented pattern space of good patterns actually consists of more than 2,000 patterns, not just 23.
I've been asked a few times about my opinion about anti-patterns. What is your opinion about anti-patterns?
Well, this depends a whole lot on what you mean by it. If you mean the original idea that Andy Koenig brought up, I'm with you. The idea is, in this case, that you outline and describe commonly applied solutions that do not resolve the problems they intend to address, and discuss why they don't do this, and then lead on to the solutions that work. This is an important vehicle for learning. Learning through failure is an important vehicle to become an expert, and that we are missing this idea in software. So this is Andy Koenig's perspective onto this. But what has been made about of that concept in other works that are more commonly known as anti-patterns, I don't subscribe to that, because often they discuss solutions as anti-patterns, which are partly anti-patterns, which are partly no patterns at all, and the solutions they suggest are also examples of anti-patterns. Nevertheless, whether something is good or bad, or a pattern or an anti-pattern, also depends on the context. For instance, if you use iterator to iterate over a collection where the client is here and the collection is remote, then using iterator is the worst idea you can do. So you have batch iterators or enumeration methods instead. So it also depends very much on the concept. And Christoph Alexander actually discusses this in his work. He distinguishes good and bad patterns, where bad patterns are similarly to what Andy Koenig describes as anti-patterns. In our current work on the conceptual foundations of patterns that we are doing together with Kevlin Henny and Doug Schmidt, we also address the notion of dysfunctional patterns and dysfunctional pattern languages. So things that are patterns but don't work in their given context to address the problem and resolve the forces well. But nevertheless, they are patterns because they are recurringly applied and seen in the world of software.
So tell us some more about the conceptual foundations that you are working on.
Yes, as said, together with Doug Schmidt and Kevlin Henney, I'm working on the 5th volume of the POSA series, which is called On Patterns and Pattern Languages. And there we reflect and revisit the original conceptual works on patterns, adjust them according to hindsight and grown knowledge about patterns, and also explore pattern languages and the space between patterns, which is from complementary patterns, so alternatives to a given problem, or patterns that often show up together in combination. We have pattern sequences, we have compound patterns, we take a semiotic perspective onto patterns, also consider the organization of patterns under problem frames, which is a notion that Michael Jackson brought up, the famous Michael Jackson from the software community, not that fancy guy.
Give us some examples, for example, for those symmetrical patterns.
Yeah, for instance, if you consider pattern complements, just to give an example, command often comes together with the command processor. So these are patterns in combination. They complement one another. In other situations, you have patterns in competition, such as builder and abstract factory. You do either the one or the other, but not both together. So we have a discussion about this. A specific patterns opens a solution space for a given problem, but it's only one specific solution to that problem, whereas pattern complements can help you to open a broader discussion about the problem and the solution space. So the problem of object creation and disposal is spawned by all patterns that help you creating things like as builder, abstract factory, a factory method, prototype, disposal method, and so on. And having all these patterns together help you to address your problem at hand much better in general than having only one solution at hand. So this is about pattern complements. Then we have pattern compounds, which is a notion originally known as composite patterns, which is an overload of the term. John Flessidis shaped this notion, so we, thanks to him, we know about pattern compounds or pattern complements, as it was called in the past. This is similar to a group of patterns that are time and again combined in a very specific arrangement. So it's not just that 2 or 3 patterns show up together time and again, but also their specific combination. For instance, you can consider the combination of observer, of composite, and others in a model view controller arrangement. They show up there and also in the same configuration, which allows you to argue, is model view controller a pattern in its own right or a pattern compound? Well, and depending on your perspective, you can argue for either position. Bureaucracy is a famous example for a pattern compound, where Jake Reilly in 1998 documented the arrangement of composite chain of responsibility, observer, and mediator to describe object hierarchies where events can be passed up and down hierarchies and across hierarchies. And these patterns always show up in the same arrangement in many, many designs. So this is about compound patterns. The next thing is pattern sequences, which is a hype topic or hot topic in the pattern right now. Pattern sequence actually describe a series of patterns that, if applied in the given order, create a system or a system part or address a specific subject in your application or organization or whatever is your target thing. Typically, each pattern resolves one specific problem in isolation. A pattern sequence lines up patterns to help resolving a broader thing, such as designing a component, let's say, that manages a network topology, or a communication middleware, how to design an orb, can be described in terms of a sequence of patterns that are applied one after the other. And there's a whole theory behind this that actually dates back or goes back and has its roots into Tony Hoare's work on communication, on theory on heap management, traces and events that happen. There's a nice paper on that theory available on the net. Yeah, and then problem frames. Michael Jackson came up with the idea of problem frames. They are rooted in the problem domain that things can be described with very simple meaning. For instance, workpiece, transformation. And there are patterns that deal with this. Or control. And patterns can address or can be assigned to specific problem frames and help you thinking about them in terms of what problems and what forces they're addressing, what solutions they produce, and things like that. So this is what we are working on.
Changing the topic a bit from patterns to architecture, what is software architecture? How would you phrase it? How is it different from design? I just ask you a few questions to which you can then answer. Is there a principal difference in architecture for enterprise and for embedded systems? How do you judge an architecture for its quality? What are your opinions on those topics?
This is a whole range of questions. The most important question is, what is software architecture? Well, first of all, what is the difference to design? There is no difference. In true English, I learned design is the activity and the architecture is an artifact. So all architecture is design, but not each design work is an architecture. There's a famous quotation, software architecture is about the important things. So what is it? Grady Booch, I think, has the characterization that I like most. He actually said, the most important design decisions define the architecture of a system, and most important is defined in terms of cost of change. So the more costly the change of your design decision is, the more likely it has a system-wide scope and therefore addresses architecture. And I like that very much, even though I don't know whether it is the ultimate characterization. But what is most important, what drives you, and what is very expensive to change. And that may be things like your distribution infrastructure. That may be things like your transaction handling. So what is architecture for the one system may not be architecture for another, because it is more tactical rather than strategic and therefore expensive.
So is there a principal difference between embedded and enterprise systems in architecture?
Interestingly, I think they share a whole set of properties, but at different edges of the same dimensions. Because even in an enterprise level system, service-oriented, which is from a frog's eye view quite different to embedded software, there are common constraints and current requirements. You have very limited memory, for instance, in an embedded system, but consider a SOA system like Amazon has. You cannot always throw more hardware against the software. In such a large enterprise system, several gigs of main memory is a very limited resource. 100 processors is not much. So interestingly enough, you apply the same principles as the embedded system development requires and the SOA level at the enterprise level again, because when you Google or go to Amazon's website, you expect quality of service, but they don't have infinite hardware and resources at their side. Total cost of ownership drives them like others. So my observation is that though there are significant differences in the types of technologies you're using, for instance, loose coupling, configuration, you have more resources, but in the end, common principles apply for the same, for both types of system.
What about the quality? How do you measure, how do you judge the quality of software architectures?
A system is, I think, of high quality if it meets the business for which it is intended, if it meets its requirements, if the requirements complement the business case, then it is successful. It should fulfill the requirements, but no more. It should be good enough. We don't want the best configurability, but the configurability that is just good enough to fulfill the requirements and the business case for the system. We want not the ultimate performance, but exactly that performance that is necessary. If you target for more, then you create design pearls that are beautiful and brilliant by themselves, but which are overkills for the systems. A system must be good to fulfill its requirements and meet the business case, no more.
How would you enforce and manage an architecture for a large distributed team, for example?
I wouldn't. I actually don't recommend to work in a distributed fashion. Well, there may be projects where this is a organization form suitable to implement stable architecture when more and more features are added. But to get the original vision of the architecture, elaborate this vision towards a stable architecture, I don't think that distributed development is successful. In this case, I'll encourage project teams to do inshoring, to draw together the experts to a common place as a small team. I've learned my lesson on C++ Standards Committee, what design by committee means. To set up a successful software project with a sustainable architecture, it doesn't require hundreds of developers from many, many countries. A small team with key experts in their field, with domain experts, with software experts, with project management experts, with testing experts, can achieve more in that case. And I think such a small setup in the beginning, and the beginning of a system could be a year, for instance, for a platform, is actually the more important, the more strategic your system is. I've learned that even when setting up a platform, something whose intent is to support a whole range of functions, even different product families, the smaller the team, the better. You don't want to be everybody's friend. Then you end up with a jack of all trades and a master of none. You need to scope yourself. You need to take decisions. And the more people talk and discuss, the less you're taking decisions.
So basically what you suggest is always have one key person, one, let's call it chief architect or one lead architect, and the others contributing, but one person making the final decision.
Well, not necessarily one person, perhaps a team, but nevertheless there should be, in case of discussion, in case of different opinion, there should be one person having the final vote, yes.
I know that you are involved currently in a Siemens-wide education program for software engineering. So then what makes a good software architect?
Oh, there are many things. The most important skill, I think, is communication. An architect who is not able to communicate is no architect. And I don't mean communication to developers. This is part of it, but communication to all stakeholders. So in terms of business, you need to communicate. You need to listen to your customers or product management to learn about the business case. Ask corresponding questions of clarification regarding requirements. You need to communicate your architecture to testers. You need to talk them to your head of development. You need to communicate it to developers. So all these persons have their stakes in the architecture, but the stakes are different. And if you can't communicate the architecture in their languages, you are lost. The other important area where communication is essential is the larger the team, the more it is you can do all the work by yourself. It is often better to identify where in your system specific problems occur or challenges are addressed and who the people are. And specifically in a larger software project where people are working in teams, it can happen that different teams are working on the same problems and resolve them differently, which creates a patchwork-like design that is hard to understand. And as an architect, you should go around and discover those places, but instead of doing all decisions by yourself, bring those people together and enable them and empower them to decide for you. And you just mentor them and coach them so that the system-wide aspects are not forgot. So communication, bringing the right people together when designing a system, when implementing it, observing what the team is doing is an important capability and skill of an architect. You need to be good in at least one or two areas, and you need to know about many topics to ultimately decide about things. But I think it is more important to let your people do the work. The architecture is shaped while it is designed and later on implemented. And what people program has an impact on the architecture. Ultimately, the architecture is in the code, are not in the paper. And enabling the people to work together, bringing them together, I think is the most important skill. And that also relates to communication.
How can people become successful software architects?
I just can quote my mentor, Kristen Nygaard here. Let them work on difficult problems. So do not start teaching software engineering, software architecture by using small examples. You can resolve them in any technology. And you, as a student or a novice, do not see the benefits of those approaches. So if you work on harder problems, which are difficult to resolve, then you may appreciate the different benefits and contributions of the various technologies. And the other thing is practice, 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 and practice. I consider software engineering not as an engineering discipline, and not even as an art, but as a craft. And to craftsman requires years of practical experience, discussion with other craftsmen, and a mentor.
I think those were already great sentences to close this episode. Anything final, Frank, to say?
Well, if you're in the field of software development, I think what is most important in today's fast-running worlds of upcoming technologies, go back to the roots. Look on the works of the old masters. and you will find how much things, refreshingly new things you will find there. And work with that, because this is technology, even if it is old, that has been proven to work, that proved its feasibility and practicability for decades. And these technologies will help you to build successful systems even today. And then you can decorate these old practices with more modern technology. Even what is now known as service-oriented architecture is common wisdom of how to build components that is more than 10, 15 years old, but it's sold as new. Likewise, what is known as model-driven software development today has been practiced for more than 2 decades in certain fields of embedded software. And we can better learn from those practices rather than from some people's advocating these technologies as brand new.
Great. Thank you, Frank.
Thank you very much.
Bye-bye.
Thanks for listening to Software Engineering Radio. If you want to get more information about Software Engineering Radio, or if you want to give us feedback, please go to our website at se-radio.net. You can also contact the team at team@se-radio.net, although we prefer entries in our comments system on the website so other people can see what you think. Software Engineering Radio wants to thank Henning Pauli for the intro and outro music, as well as Libsyn for providing the bandwidth. This episode of SE Radio, as well as all other episodes, is licensed under Creative Commons license. See the Software Engineering Radio website for details.